to the view controller. So let me go into my view controller and do the interesting part now when it comes to code meeting nib files. So inside of my view controller, and if you want to sort of spoil the results, all of this code is in the ATM example in today's printout, an online code. I'm going to go ahead and import the account class, or the account header file, so I can actually use it. In terms of the view controller, I don't actually want any instance variables per se, at least ones that aren't properties, but I do want a few properties, one of which is going to be an account. So I'm going to give myself a pointer to an account, one of which is going to be a, let's say, unsigned long amount. What am I going to use this int for, do you think? What's this int going to represent in the program? Just literally that dollar amount. I need some variable, some 32 bits or 64 bits to represent the number that the user's typed in before it gets deposited in their account and in turn in the unsigned long called balance. So I'm going to put that into my view controller here who's controlling this interface. So this is my .h. App property, I need a couple other things now, and this is the new feature for now. IB outlet, interface builder outlet of type UI label. And it's going to be called arbitrarily the balance label. And then I want another property that's an IB outlet that's also a UI label that's arbitrarily going to be called deposit label. In other words, I have created an interface builder by dragging and dropping two labels, three actually, but only two of which I care about changing. The amount at top right and the balance at bottom middle. Programmatically, if I'm going to update those things, I need some way of wiring, so to speak, my code to that GUI interface so I can talk. And how do we do this in C? Pointers. Pointers allow you to access something elsewhere. So by saying UI outlet, this is going to allow me to create in the nib file literally a solid line from one thing to another. So we'll see that in just a moment. So as for the properties, I'm going to fly through this a little bit, mostly because we've already talked about these things. They're all going to be non-atomic, but for today, take for granted that you want to say strong almost always when a pointer is involved. Not copy, not assign, you want to say strong. But again, we'll tease that apart when we talk about memory. This case here, it's just a primitive, so I'm going to say non-atomic assign, and I'm a little anal. I just do these things alphabetically, but you can order them any way you want. Non-atomic for this one, strong, and then non-atomic strong for this one. So in short, we'll spend more time in memory management on these parentheticals, but for now, all we have is four properties. The only new feature in this conversation is IB outlets. And we're about to add one other detail. So in addition to these properties, I'm going to have a couple of methods associated with my controller that I can call. And these return types are going to be called IB actions. And that's the second and last new buzzword now. Clear is going to be one method. And that method, I'll tell you, is meant to clear the interface. When I hit the clear button, I want the numbers to go away. I have another IB action now whose name is going to be deposit. This is going to be the method that's called when I actually deposit a value. I have another one here, another IB action that's going to be digit. This is the method that's going to be called anytime a digit is touched on the interface. And lastly, I have another IB action that, no, I don't. I have another method called void, return type void called show. And this is just going to be a method, as we'll see, that's going to update my user interface. Thank you. Perfect. OK. So in short, I have four properties, two of which are something called outlets now. I have four methods, three of which are called actions. Actions refer to methods, outlets refer to properties, and these things, as denoted by the silly looking circles there, are now going to allow me to wire things up in my user interface. So let's see what I mean by that. So I'm going to go back to my nib file. And this time, I'm going to first click this arrow just to give me more room here. Notice to the left of the graph paper, you see a sort of textual representation of all of the widgets that I've dragged and dropped. So notice I've got the big view, and then I dragged on top of that view, the rectangle, all of those buttons. That's why they're appearing there. At the top are two special placeholders called files owner and first responder. Let's ignore first responder for today, but files owner is actually relatively straightforward. That is an icon that represents the owner of this nib file. The nib file is called viewcontroller.nib. The owner is then viewcontroller.m. in this case. So because I now have a graphical representation of my M file, I'm going to be able to connect dots, so to speak, in this picture. So here's what I want to do. I want to go ahead and hold Control and click on the 7 and drag over to Files Owner. Notice how it's highlighting and literally a blue line is being drawn, and let go. And what I see here is a list of events. What events can I invoke when 7 is pressed? So what method do I want to call when 7 is pressed? Digit. So I'm going to go ahead and select digit. And sure enough, if I now control click or right click on the 7, I see a whole bunch of events that this button could send. Turns out you can do a lot of things with a button here. Touch up inside is literally that, like touch and then upwards inside of the button will induce this event. So that's the idea of touching a button. What that means is, because there's now this connection, when you touch up inside the button, the file's owner's digit method will be called. And you know what's going to be passed to the digit method? Well, what was its parameter called? It was called sender. Remember, I did this, and I didn't mention what I was doing at the time, but notice I did this, ID sender. Take a guess. What are you going to be handed a pointer to in your digit method? The button. And because the button has that thing called a tag property, this is how programmatically I'm going to get access to the number of the button and then actually do something mathematically with its value. Now let's do one in the other direction. It'll get tedious if I wire them all up, so I'll sort of pull a pre-baked application out of the oven and show you how this works in a moment. Let me go ahead now and drag holding Control from Files Owner to Amount and let go. Notice now in the opposite direction, because I have outlets in addition to actions, I can now connect my M file programmatically to the labels. And so now this is the deposit label. I can select that. Then let me do it again. Control on Files Owner down to this label, not this one, and let go. I can then connect it to balance label. So what does this mean? Even though I've created my GUI using this drag and drop interface, recall that in code, I have these 4 pointers. Well, normally in CS50 and in C and in Objective-C more generally, if you want a pointer to have a value, you better use the assignment operator. You better use the equal sign. Well, what I've just done is I've supplanted the equal sign with this big blue arrow that I drew that is doing the assignment for me. So when I click Command R to run this program, this view controller object is going to have these 4 properties, 3 of which are pointers, and those pointers will automatically point to the address of what objects in memory? The UI labels in memory. So I don't have to instantiate UI labels because they're in the nib. That will happen for me automatically, but now that pointer will be set for me. So now if I open up the prefab version of this code, just so I don't have to tediously drag and drop for all of those buttons, you'll see that if I go back to my nib file, I've done the same exact thing here. And if I control click on Files Owner, notice how much work I did here in wiring things up. This is just an exhaustive list of all of the connections in different directions that are now wired up, either the pointer assignment or the event handlers that are configured. So if I now go ahead and hit Command R and run the entire code and pull up the results here, notice I can type in something like 20 and then click Deposit, and it ends up over there. I can do 11, deposit, 31, goes back to 0. And I can do this now programmatically because I have pointers controlling those labels and the underlying code. And the underlying code, if we look at the M file, is actually relatively straightforward. Let's just look at 1 or 2 in closing here. This is the digit method. I declared it in the H. Here's the .m file. What do? Well, I first cast to a UI button the sender, because it's a generic ID, which is kind of like a void star, but that can also be nil. I just want to treat it as a button, so that's common convention there. Then I want to update the amount in the screen, so self.amount. This is my int property, or unsigned long, equals self.amount times 10 plus b.tag. And this is just a brilliant way of moving the digit that's currently on the screen one place to the left, right, multiply by 10, then add in whatever the numeric value of the tag is. And the reason for the tag to be clear is it would just be hackish to look at quote-unquote 7 or quote-unquote 8, which is a string, then convert it back to an int. The tag is just a better design in that it's defined as an actual int. And then if we look at something like show, notice that showing the interface after I've clicked a button is going to involve updating self.balance label. It has a text property, which is literally an NS string pointer. And I'm going to put in that pointer the result, if you think back to 50, a string that's formatted with LLU, which is unsigned long, self.account.balance. And there's a few details we didn't peel apart there, but the biggest takeaways, hopefully, from today's example there is how you connect GUI to code so that they can then start crosstalking. And that's where we'll pick up after spring break. So we'll see you then.